afternoon, everybody. Thank you for the opportunity to present. I'd like to share with you the progress of my PhD research so far, which is the application of artificial intelligence in COVID-19 severity prediction. My name is Márton Rakovics, and I'm a statistician, assistant lecturer at the Department of Statistics, Faculty of Social Sciences at Translational University. Obviously, a PhD student here as well. My supervisor is Andrea Harnos, and my SMS is Fanni Mezdaric, and the statisticians helping me are Péter Fehérvári and Tamás Kói. My vision is to make AI an everyday tool in healthcare, and some of the steps I aim to take are development of AI models for disease severity prediction, different problems. So I have two projects ongoing currently. First one is a meta-analysis. It's the investigation of the efficacy of early severity prediction models of COVID-19. I've started this in September, and my co-investigator is Gabriela Robski, and I have two project students working with me as well, Márton and Korne Gatter. So just a brief background on COVID. There have been more than 655 million cases worldwide so far, with around 6.6 million mortalities. And right now, currently, there are about 500 new cases daily, which is around the level of late 2020. So even though the WHO says that it's not a global pandemic anymore, it's far from over. And characteristic of this viral infection is sudden worsening of patient condition. Around 14 to 30% of patients require ICU, and the survival rates are markedly different for low and high-risk groups. So it's very important to make a correct decision on ICU admission. This will improve patient outcomes. And it's important to note that a recent Swiss study showed that even in such a highly developed country, ICU occupancy over 70% results in a decline of patient outcomes, even when controlling for other factors. So it's key for both patients, clinicians, and the healthcare system in general to make highly accurate predictions for patients as early as possible. And my aim is to quantify the performance differences of the many currently available prediction tools to sort of to make a suggestion to clinicians. So my question is, which prediction model has the highest performance? The patients will be COVID-19 positive patients, but only hospitalized patients. And so I will be comparing these different the model types, deep learning or machine learning models, some clinical scores. There are many different types of models. And the outcome I'm looking at is binary outcome. It's severity. It's like basically death or need for mechanical ventilation. And statistics I'm aggregating are area under receiver operating curve and sensitivity and specificity. My hypothesis is obviously that deep learning models are superior to simpler models, and this will hopefully, this project will result in better patient outcomes for severe cases. I've conducted the search in the 4 major databases, including Cochrane COVID. And we had a huge number of hits, 27,000. And after all the selection process, we ended up with 522 eligible full texts. And I can show you already some preliminary results. It's just a small sample, a subgroup of 27 studies. So I wouldn't advise to draw conclusions based on this, but it's interesting because this subgroup is should be very homogeneous because it's the same model. It's a multivariate logistic regression. The outcome in this case is mortality. And the setting is, these are mostly from China and from early 2020, so from the same period. And this is looking at AUC. But even for such a supposedly homogeneous group of studies, we have vastly different AUC statistics. So it's an open question for this project. What are the possible causes of this large heterogeneity, and why are there these outliers? My second project is the development of a novel deep learning severity prediction tool. Now, obviously, I hope to build on the knowledge gathered from the first project. This one's going to be analysis of the COVID-19 registry data, which is actually two registries, the COVID-19 registry and biobank, and the Coron app registry. I've listed some of the details. You can see the patient numbers from all the different centers. And data domains are include the fundamentals, demographic characteristics, and a lot of lab data, blood and saliva samples as well, comorbidities, and even vaccination. And there are 4 follow-ups. I would like to express my thanks to all who work in these registries, because my project would obviously not be possible without them. I've already talked a bit about the background of the disease, COVID, so I just would like to extend this, some background on the methods. A very recent Nature Medicine report showed that there's considerable progress in using AI in the medical field, but most notably in medical imaging. But there are opportunities they've listed for developing new prediction models, similar to mine. One is semi-supervised learning. This is a transfer learning from non-image data. And multimodal data, which is the use of unstructured text data in my case. And my aim is to create accurate, data-efficient, and interpretable deep learning model for COVID-19 severity prediction. And this is a brief outline of the model structure. It's not the exact model I will be using, just to give you a rough idea of what I plan to do. The upper picture shows sort of the pre-training part, which is the creation of medical concept embeddings from large text corpus. And based on these embeddings, we can construct knowledge graphs. So if you look at the lower picture, you can see that we can use this graph with the registry data to use a graph neural network model to make predictions. And this way we can combine external knowledge and the specific data in the registry to hopefully achieve better results than it was previously possible. So the question is, can we use this external medical knowledge to inform severity prediction with same patients? And the model type I will try to develop is a graph transformer model, and I will also do severity prediction. And so in summary, these are my 2 topics I'm working on currently, and I hope to finish these in the first half of the next year. Thank you for your attention. Feel free to ask any questions if you have some.
Thank you for your presentation. I was wondering if from those 27 articles that you included, how did they, what were the variables that they used for this prediction tools? Is it too different from article to article? And could this be a confounder to predict severity? Thank you.
Yes, thank you. Excellent question. I didn't mention this, but that is what we think right now, that because of the different variables used, that would probably explain most of the heterogeneity. So we'll include that in kind of a meta-regression and see what we get. Yes, exactly. Yeah.
I would like to ask one question. Sure. That you mentioned that 14 to 30% needs the ICU, and I would like to ask that this data, this percent, is still valid right now after the vaccinations and etc., or maybe these numbers are lower now? Yes.
Yeah, I may not have been precise because it's true for hospitalized patients. So vaccinations greatly decreased the rate of hospitalization, but it also had an effect on this. So this is not exactly true right now, but it's true for most of the data I have, which is from 2020.
Thank you for a nice talk, and I have one question. The prediction means you're going to predict the prognosis and mortality and any kind of complication for the patients, and I think that all of the patients had some intervention like treatment, and then what's your plan to rule out the effect of treatment for this prediction model?
Well, this is where we definitely have to make subgroups for models where they included treatment, and there are which did not. And actually, for early data, there wasn't much of an effective treatment, so it doesn't. I'm not sure how much of the difference this makes.